Hello, my gentle and of course very modern apes. Some big news just came out, you guys. Colossal news about a gigantic subject. I'm of course talking about the recent paper that came out discussing the reason for the extinction behind the largest primate to ever live, Gigantopithecus blacki. Actually, I think it's black eye. I think typically when you have like an eponym name for an organism, it's whatever that person's last name was and then I. But I like blackie better, so that's how I'm going to say it. It's high time we normalized because I want to as a reason for mispronouncing things. When I say this is big news, I don't just mean it as like a haha, it's a pun, because the subject, Gigantopithecus, is in fact big. But actually, this article made the front page of Nature in this absolutely epic cover. And the reason for this is pretty straightforward. The study that these guys performed is absolutely insane. We're gonna get into all of that in just a minute, but first a little bit of background information. Who or what is Gigantopithecus blacki? Well, like I said earlier, it's the largest primate to ever live. This thing is typically described as being 2 to 3 times the size of modern-day male silverback gorillas, capping out at almost 700 pounds. Now, granted, that's going to be the biggest individuals, right? Like huge adult males would be around 700 pounds. But it's still kind of insane to think about because if these guys stood up on their back legs and walked bipedally for any period of time, and it serves to reason that they could, given modern-day orangutans, their closest living relatives, can and do this often, they would have towered at like 9 to 10 feet tall. The time period that they've previously been thought to range has been like 2.6 million years ago to within the last million years, which means that members of our own genus Homo, as they were expanding out eastward, probably Homo erectus, would have and likely did encounter these gigantic cousins. I'm just imagining myself as a member of Homo erectus and I'm doing my gathering or my hunting and I crest this hill and look down into the valley into one of my favorite foraging spots and there's like a troop of Gigantopithecus blacki feeding down there and I would be like, I think I'll try by the river instead. Gigantopithecus, like I said, is most closely related to modern-day members of genus Pongo, so the modern-day orangutans, but it would have led a life that was probably pretty different from our modern red ape friends, and the reason for this is because of its enormous size. Modern-day orangs are one of the biggest, like, arboreal creatures out there, right? Like, it doesn't get much bigger than an orangutan for something that lives its entire life up in the trees, especially for the big males, which is why they typically have to stay closer to the trunks of the trees, to the middles of the trees, while the smaller females and juvenile males can feed and forage at the terminal ends of branches. But like this wouldn't have been the case for Gigantopithecus blacki. Males, females, juveniles, pretty much any of these guys are not going to be able to be doing their foraging in the trees, and so as a result, they were terrestrially bound. Their enormous size led some paleoanthropologists and paleoprimatologists to suppose that Gigantopithecus might have foraged on things like bamboo rather than fruiting bodies because bamboo is on the ground. And also the molars of Gigantopithecus shared some similarities with the molars of modern-day pandas. However, the idea of a Gigantopithecus blacki bamboo specialist kind of got kicked to the curb with a microwear analysis of the molars, which showed that Gigantopithecus got cavities, and you don't typically get cavities from bamboo, you get them from fruit, at least in primates, which suggests that Gigantopithecus was probably eating a lot of different things in its landscape, basically whatever it could get its big, meaty hands on. That's not to say that Gigantopithecus was a generalist, however, because there are adaptations to the molars that suggest that this thing was focusing its attention on abrasive foods. And what I mean when I say that is its enamel is ungodly thick. To put it really simply, the enamel is the hardest portion of the tooth. It's actually one of the most durable substances in biology. And if you have really thick enamel, that suggests that what you're eating requires a lot of protection for the tooth. Because otherwise, if you're eating a ton of abrasive foods and your enamel is thin, you're going to wear through all of that enamel and then start damaging the cementum and then eventually the pulp of the tooth. Then you can't eat. and then you die. Thick enamel is one of the adaptive strategies for having a diet that has really abrasive foods that are hard on a tooth. There are other strategies to this type of lifestyle, right? Like you can have the ever-growing teeth that you see in most rodents. If the tooth is forever growing, it's really hard to damage it all the way to the pulp. You can have teeth that replace themselves over and over and over again, so that way when the tooth wears too much, it just kind of is pushed out by a new set that is undamaged. So there are many ways to skin a cat. But in the case of primates, and specifically in the case of apes, we see this through the Miocene all the way up to present, thick enamel typically implies a diet that has a lot of foods that are going to wear down on that enamel. This has led most paleoanthropologists and paleoprimatologists to suggest that Gigantopithecus might be doing something similar to what we see in modern-day gorillas, which is that what it's mostly eating and what its teeth are actually adapted for is these really abrasive, low-nutrition, but very widespread foods, whereas when it has the opportunity, it's always going to choose fruit because fruit is tasty and more nutritious. So in the case of gorillas, they mostly eat leaves almost all year round, but when there's abundant fruit, they will partake. We refer to their primary diet as the fallback food, the thing that it can eat whenever it wants, but that's less desirable than the more metabolically beneficial fruits, or sometimes even like animals, like small vertebrates, insects, things of that nature. And the argument goes that if you track the cusp morphology for the molars of Gigantopithecus through time, you see them become more and more specialized towards these fibrous fallback foods, as opposed to the more generalized molars that you see in the members of Pongo that are living at the same time. I like Gigantopithecus too because it has a really interesting pattern of sexual dimorphism in the canine teeth. You know I had to bring it up. It's my favorite subject with regard to primates. Which primates are sexually dimorphic? Which ones are dimorphic in their canine teeth? Why are they dimorphic if they are? Why aren't they if they aren't? Gigantopithecus is weird because what we know from its remains suggests that it was pretty dang sexually dimorphic in body size, but not so much in canines. In fact, the canine teeth appear reduced in males and females alike. This suggests that Gigantopithecus had a really high level of male-male competition for access to females, but that they probably weren't using their canines very much in fighting, whether that's because they were accomplishing it specifically with large body size, or because the canines, being large, inhibited them in some way with their food processing. We don't really know. Maybe someone will find it out. I hope it's me. Gigantopithecus is known in pop culture as well. You may remember a Gigantopithecus somewhat recently in the media because Gigantopithecus is what Christopher Walken plays in the live-action remake of The Jungle Book. Christopher Walken is a big Gigantopithecus, and he does sing the King Louis song. It's great. Another pop culture icon for Gigantopithecus would be Bigfoot, unfortunately. A lot of the Bigfoot people seem to believe that modern-day Bigfoot comes from Gigantopithecus, which is absolutely crazy to me, because Paranthropus is right there. I'm not a Bigfoot believer myself, but I mean... So thus far, we have an enormous, semi-specialized herbivorous ape that's living on the same landscape as more generalized orangutans, and also there are gibbons too, in the landscape of China, like some 2 million years ago. Gigantopithecus was first discovered in the 1930s by von Koenigswald, who's in China wandering around in a Chinese apothecary shop when he stumbled across an item that was being sold labeled dragon teeth. And lo and behold, they were actually Gigantopithecus molars. I don't know a lot about von Koenigswald as a person, so I was reading up on his Wikipedia page, and according to that, he actually couldn't describe the type specimen for Gigantopithecus right away, and indeed it wouldn't be until the 1950s until he could actually get that manuscript out, because he was in an internment camp helmed by the Japanese, because it was World War II. Since then, the paleontological record for Gigantopithecus has gotten a lot better in some ways, but in other ways, not really better at all. So we have thousands of teeth from this species and 4 partial mandibles, but that's it. We have no postcrania, nothing from the face or the brain case. It's just a lot of stuff related to the teeth and the jaws. And the reason for that is the same reason as to why the record for gibbons and chimpanzees and gorillas is also so poor, which is that Gigantopithecus lived in a rainforest. It lived in tropical to subtropical regions, and in these areas, the soil is notoriously acidic. It is hostile to fossil formation and paramineralization in general. So why do we have so many teeth for Gigantopithecus? The blame has been pinned on rodents, and specifically porcupines, because apparently a lot of the Gigantopithecus material is found in like ancient porcupine dens, and they have gnaw marks from ancient porcupines on them. Evidently, porcupines gnaw on bones and teeth to get the nutrients necessary for building and maintaining their quills. So we have ancient porcupines to thank for this. Good job, you guys. Modern-day Asia is extremely friendly to primates in its ecosystem. In Southeast Asia, we have a gazillion different types of gibbons. In peninsular Malaysia, we have orangutans, and China in general has lutongs and langurs and other leaf monkeys and snub-nosed monkeys and macaques. There's just a billion different primates calling the area home. But you know what's missing? A 700-pound ape. By 100,000 years ago, certainly, Gigantopithecus is completely gone from the picture, wiped from the landscape. It has gone extinct. So what happened? Why is Gigantopithecus gone while we still have all of these other primates calling the area home? Well, guess what, sports fans? We can actually find out precisely why, because this article is open access. So I would like to give a hearty thank you to Zhang and colleagues, because frankly, publishing an open access paper in a journal that isn't strictly open access is extremely expensive, or at least it can be extremely expensive. So clap for Zhang and colleagues in the comments. Do it, or lose your status as a gentle and modern ape. This paper is titled The Demise of the Giant Ape, Gigantopithecus blacki, and I think that's a pretty metal title for a paper. I think it sums up the situation nicely. Your ideal paper title, by the way, should simultaneously be cool and tell you precisely what the paper is about. Now, recall what I said earlier about this paper, how the reason this paper is so awesome and so interesting is because of the sheer work that was put into it, the audacity of these people to do this kind of science. It makes the rest of us look bad. So let's get started here. The largest primate ever, and one of the largest Southeast Asian megafauna, Gigantopithecus blacki, persisted in China from about 2 million years ago until the late Middle Pleistocene, when it became extinct. F's in the chat for Gigantopithecus. Its demise is enigmatic, considering that it was one of the few Asian great apes to go extinct in the last 2.6 million years, whereas others, including orangutans, survived until the present. The cause of the disappearance of Gigantopithecus blacki remains unsolved, but could shed light on primate resilience and the fate of the megafauna in this region. Here we go, you guys, just appreciate what was done here. Here we applied 3 multidisciplinary analyses, timing, past environment, and behavior, to 22 caves in southern China. We used 157 radiometric ages from 6 dating techniques to establish a timeline for the demise of Gigantopithecus blacki. We showed that from 2.3 million years ago, the environment was a mosaic of forests and grasses, providing the ideal conditions for thriving Gigantopithecus blacki populations. However, just before and during the extinction window between 295,000 and 215,000 years ago, that is a tight age range, there was an enhanced environmental variability from increased seasonality, which caused changes in plant communities and an increase in open forest environments. Although its close relative, Pongo weidenreichi, managed to adapt its dietary preferences and behavior to this variability, Gigantopithecus blacki showed signs of chronic stress and dwindling populations. Ultimately, its struggle to adapt led to the extinction of the greatest primate to ever inhabit the Earth. Those of you who watched my mass extinction video probably see a familiar pattern here, which is that when faced with environmental change, generalists typically inherit the landscape while specialists are more at risk of going extinct because they have a smaller range of food items to pick from. And if those food items are wiped out or severely diminished, they don't really stand a chance because their morphology and behavior are specialized for that specific thing, whereas the broader generalists have a lot more to pick from and a lot more to fall back on. It's especially sad because Gigantopithecus had a pretty solid fallback food. It just so happened that that fallback food was one of the plant species that was hit particularly rough by this environmental change. So let's talk a little bit more about this paper and what they did. So they talk a little bit about the background for what we currently know about Gigantopithecus, the material known from it, its discovery, etc. Then they talk about the sites that Gigantopithecus blacki material comes from. They say very few of these Gigantopithecus blacki sites have been dated using more than one radiometric technique, and thus the timing of extinction remains uncertain. So, little hint there for the problem that they're going to fix with their 140 plus dates that they report on in this paper. The current timeline for its presence is 2.2 million years ago to 420,000 to 330,000 years ago. So already we know from the abstract that not only have they pushed the extinction to more recently in time in the 200,000 year bracket, but they've also really tightened it to like 215,000 to 295,000, if memory serves, from what we literally just read. During this time, Gigantopithecus blacki underwent morphological changes, including an increase in tooth size and dental complexity. So again, that's what we were talking about with that cusping pattern, seemingly indicating a dietary change in response to ecological pressure. Reconstructions of Gigantopithecus blacki diet are based on the dental anatomy and indicate a specialized herbivore with adaptations for the consumption of abrasive foods, heavy mastication of fibrous foods, and a fruit-rich diet. So again, we already discussed all of this. So the authors want to suss out why Gigantopithecus blacki went extinct. So to do so, you got to do a couple of things, right? First, you have to narrow down the extinction window. When did this animal actually disappear from the fossil record? Then you have to establish the type of community that it lived in, and then you have to establish the type of change that it underwent over time to see how it's sort of responding to the changes that either were or were not actually occurring based off of the environment, which is why they have classified here in their 3 lines of evidence: timing, environment, and behavior. So this figure 2, is really cool. It's a little sampling of their full database, and let's kind of dig into what we're looking at here. In figure 2a, so this section highlighted by the timing bar over here on the right, you have time on the y-axis, age, the age of the sample, and the location there on the x-axis. And basically what they're doing is they're taking radiometric samples from all of the different cave sites that Gigantopithecus blacki can be found in China. This is so we have a really good idea as to like the first and last appearance of Gigantopithecus blacki, and specifically when that extinction event is actually going to occur. And remember, they got 157 radiometric dates from 6 different techniques, which is kind of blows my mind. That is just an insane amount of work. In section, or rather in figure 2b here, section 2, the area labeled environment, they've sampled pollen from a myriad of different species from the fossil record. And they've classified them as ferns, non-arboreal, so terrestrial or more or less terrestrial, and arboreal. And what you can see is as we move through time from the firm, like Gigantopithecus is just doing fine area as established by being before this extinction window gray bar that passes down through all 3 categories. It's mostly arboreal plants with some non-arboreal species and a few ferns, to becoming primarily terrestrial, dominated by ferns and non-arboreal plants to the exclusion of arboreal plants. So the extinction window is characterized by a trend towards less forested and more open, more grasslands, things of that nature. The last section on behavior is looking at a couple of different things, and primarily they're comparing 2 different primates, Gigantopithecus to Pongo, so Gigantopithecus 2 and orangutan. It's not the orangutans that we know of today, it's a different species, an ancestral species probably, but occupying the same general niche. So in section C, we're comparing Gigantopithecus and Pongo in the complexity of the teeth using a microwear analysis, and underneath we're looking at the difference in their anisotropy. So complexity is exactly what it sounds like, right? It's how complex is the surface of the tooth, and that can tell you a little bit about like the given adaptations of the organism and the resources that it's probably exploiting. And what you can see is that looking at the extinction window here, both Gigantopithecus and Pongo see a decrease in the complexity of their tooth surface. This is compared to the anisotropy, where both see a decrease in anisotropy on the tooth surface, but the Gigantopithecus decrease is significant compared to the decrease that you see in Pongo right before the extinction window, and then it actually kind of starts to climb during the extinction window. Anisotropy is kind of tough to define. Well, it's tough to define for me because I'm not a microware person, but my understanding from the work of Peter Unger and colleagues is that if the anisotropy value is high, you're looking at an organism that's exploiting a lot of like tougher, more abrasive foods. So again, what we would expect from Gigantopithecus, and specifically you're looking at like the length and direction of striations. So striations are these little slices that are created on the surface of the tooth when you're eating these abrasive foods. So high anisotropy means a lot of striations, which suggests a heavier reliance on those abrasive foods, if my understanding is correct. So looking at that here, we're seeing a decrease in the exploitation of these foods by Gigantopithecus, which, if I'm understanding this correctly, falls in line with the decrease of the availability of those resources. And that sort of is going in tandem with the complexity, more or less, for Gigantopithecus, whereas Pongo is fluctuating a lot less, and specifically the anisotropy, or the reliance of like fibrous foods, is actually increasing during the extinction window and then decreasing once the extinction window kind of crescendos and then starts to end. Taken together, my understanding of what's going on here with the complexity and the anisotropy and the differences between Gigantopithecus and Pongo is that before the extinction window, Gigantopithecus is relying a lot more on these fibrous foods that are giving these kinds of signals in the teeth, whereas Pongo has a more generalized diet. So when the extinction window appears and we're seeing an increase in seasonality and a decrease in these types of food that Gigantopithecus relies on, you're going to see a decrease in those kinds of striations in the teeth, as well as the complexity required to process those, because there's just fewer of them around. Pongo doesn't experience the same stress because it didn't rely as much on those resources in the first place. Figure 3 here puts everything together and then details some of the primary points in the text, so let's appreciate that. First, they note that their pollen study demonstrated that the key to the Gigantopithecus blacki extinction is not necessarily the decrease in the arboreal cover itself, but rather the influence of environmental variability in changing the composition of forest communities, particularly the increase in disturbance taxa. So it isn't necessarily like by itself that the forest cover is disappearing, but it's the seasonality that comes with the disappearance of that forest cover that's, if again my interpretation is correct here, interrupting the year-round availability of some of the resources that Gigantopithecus blacki may have become accustomed to. They talk about how this compares to Pongo by saying pre-extinction window Gigantopithecus and Pongo both lived in closed canopy forested environments with stronger biogenic banding, probably reflecting a larger diversity of food sources, including seasonal fruits and flowers and periodic water consumption, as indicated by the clear lead banding. The most likely food sources would have been in greater availability all year round, causing only discrete stress in the population. They say, with the exception of one individual, throughout the extinction window, Gigantopithecus blacki seemed to have maintained a more specialized closed canopy niche, relying on perhaps a mixture of forest plants. This specialization during an environmental shift may have caused a more diffused biogenic signal in individuals' dental tissue, thus suggesting a greatly reduced dietary diversity, less regular water consumption, and increased chronic stress in the population. So this increase in seasonality is throwing everything for Gigantopithecus populations out of whack. They don't have the same access to water, they don't have the same year-round access to the food resources that they like to exploit, and their already narrow range of foodstuffs is becoming even narrower. They go on to talk about how Pongo evidently didn't have that problem as it shifted to exploit the more open seasonal habitats, perhaps continuing to exploit the seasonal masting of fruit as modern members of Pongo in Borneo do today. That's super cool, and I didn't know that there was a through line that existed from ancient Pongo to the behavior of modern orangs. They mention a little bit more about Gigantopithecus's reliance on its sort of low nutritional fallback foods, the ones that were in more plentiful supply. So I'm guessing that they have a series of fallback foods that they tend to exploit, and they're being forced to move further and further back on the less and less and then least nutritional fallback foods that are still available and withstanding the seasonality and the change in the local environment. The increased consumption of fibrous foods in Pongo over the extinction window as well may indicate a better switch to fallback foods and an overall more flexible and balanced diet. Then they say the first DMTA analysis on the entire range of Gigantopithecus blacki material provide a unique insight into its ability to adapt and its potentially poor choice in fallback foods. So I wonder here, this is like my own thoughts, right? I wonder if maybe it's not necessarily that Pongo picked a better fallback food than Gigantopithecus, or that Pongo was better adapted to more fallback foods than Gigantopithecus, which may have been forced into this narrow niche of like a really cruddy fallback food. I wonder if it's because Pongo is still arboreal, and even though there's less forest cover, Pongo can still go up into the forest cover, like the trees that exist, and maneuver to the terminal ends of those branches to exploit more fruits. So it's maintaining a higher level of frugivory in its diet, and it's able to supplement its really cruddy fallback foods, which may have been just as bad as Gigantopithecus, who couldn't incorporate those fruits into its diet because it couldn't get up into the trees to where the fruits are. And like with less fruits around, Pongo would just get to them first before they could ever fall to the ground and be available to Gigantopithecus, who is like ground bound here. So they actually talk about this a little bit. They say the reliance of Gigantopithecus blacki on fruits and lower nutritious fallback foods created a higher risk foraging strategy and, combined with its much larger, less mobile body size, made it more vulnerable to changes in forest structures. Moreover, Gigantopithecus was exclusively terrestrial, possibly with a smaller geographic range, but periodically traveled down the valley for water consumption, whereas Pongo was more arboreal, mobile, and semi-solitary, collecting water in the leaf canopy. Moreover, the unique dentognathic features and giant body size of Gigantopithecus suggest a higher demand in food uptake and slower and more delayed growth pattern, which may imply a lower reproductive rate. That's true too, right? Like, it's not just that Gigantopithecus is eating cruddy food, it's having to eat a lot more cruddy food than Pongo, and like even if it had access to fruit, it would need a lot more of it to keep its metabolism up and running just because it's so much bigger. They say although Gigantopithecus blacki increased in tooth size over the Pleistocene, implying an increase in body size, also Pongo decreased, making it a more agile adapter. Pongo also demonstrated a flexibility towards open habitats, potentially moving in smaller groups, and was able to adjust its behavior in response to environmental variability, causing a less stressed population. There's a section at the end here of the body of the work, like excluding all of the methodology, because the methodology takes up the majority of this manuscript, that's like, oh, by the way, hominins probably did not play a role in the extinction of Gigantopithecus and other megafauna in the region, which, like, yes, finally, something that isn't our fault. Hi guys, Future gutsickgibbon here. This video was delayed by almost a week because I was talking to my colleague who does microanalyses and understands it pretty well and has actually worked with some of the specimens in this very paper. And while I think the general trend and sentiment of this video still holds, which is why I'm releasing it, there's some minutia that I'm not 100% sure on, mostly to do with the microanalysis. So again, like overall the concept stands, but some bits and pieces on the microware for the anisotropy and the complexity, specifically looking at the sample sizes for some of the pretty big changes that they're reporting in that major figure, may need to have a second look at, like from me, once I understand this concept a little bit better, but I still wanted to get it out because I think it's really cool, and again, I think most of this holds. It might just be some minutia in understanding of microware on my end, so I just wanted to put this in here so you're aware. Don't take my microware stuff as gospel, the rest is fine. So putting everything together, I think we have something of a sad picture, right? You have a large, social, semi-specialist primate here that is faced with environmental change. And because of its large body size, it has a slow life history and is slow to adapt, especially compared to the other organisms that it shares the landscape with. It is unable to feed on its preferred high nutritious food source, and so has to switch to lower nutrition fallback foods, and it can't find water as easily or as frequently, due in part to the fact that it's so big that it can't get up into the trees where water can collect on the leaves. Pongo, so the orangutans and the gibbons, as well as some of the monkeys that are probably living in the area and other arboreal animals, are fully capable of getting up there and having their water needs met, but not so with Gigantopithecus. Further, these low nutrition fallback foods are themselves probably being impacted to some degree by the change in environment, and seasonality is perhaps making them less available all year round as well. All of this together, for a long enough period of time, spelled doom for the biggest primate to ever live. Oh, that sucks. That sucks so much. I really wish we lived in a world that had Gigantopithecus still in it. Can you even imagine encountering something like that? I bet they were a sight to behold. Of course, we should count our blessings because we still do share the world with plenty of really cool, really interesting, and really quite large primates. And we ourselves are actually a part of that group when you think about it. Technically, humans count as megafauna. You should look that up. The threshold is actually quite low when you think about it. Most animals aren't that big, and we're pretty big. Anyways, what a phenomenal paper. What an insane, obscene amount of work to do to make a point like that. But wow, how lucky are we to have that paper available to us and to have the mystery of Gigantopithecus's extinction at least mostly solved. And I really enjoyed covering it with you today. So if you like what I do, please consider supporting me in the free way. That's liking, commenting, and subscribing. And if you want to support me in other bigger ways, you can become a patron. Patrons get their names at the end of videos, and they also get early access to videos sometimes. And you should really consider being a patron right about now, because I actually just finished, more or less, there's a little bit of tweaking that still needs to be done, the brand new intro, as well as a longer version of the intro that will be reserved for special occasions. It's fully animated, it took me forever, and I really like it, and patrons will have early access to that. So now's a good time to consider becoming a patron, maybe. And other than that, I'll see you real soon next time.